Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this couple of videos we are going to take a detour from pandas and talk about basic descriptive statistics. And the reason for this is that in coming videos, when we start using some of these statistical methods in the code, you'll be able to interpret what the output is, and you'll have an intuition about what's probably happening in the background when the code ran to give you that particular output. So here in this couple of videos, we're going to talk about all these topics that are put here on this slide, starting with what is population and sampling statistics, and then what is histogram, mean, standard deviation, all the way up to geometric mean and harmonic mean. So there's a lot of stuff in here, and I tried to make one video, but it was more than an hour. So I've broken that up into multiple videos, and in each of those videos you'll see parts of this being discussed. So I hope you learn from these videos. So let's get started. So for geometric mean, let's look at an example. So here we have, let's say, four brands of laptops, A, B, C, and D. And now you have a task of finding which brand has the highest user rating. And so you've collected two sets of rating. One has a scale up to 5 and the other one has a scale up to 100. Now if you just take average arithmetic mean of these two, so 3.3 and 88, so add them up, divide by 2, you get a rating of 45.65. If you do that for all other observations, all other ratings, then this is the kind of arrangement of user rating that you get. This is telling you that the brand C has the highest user rating as compared to brand B, but that is likely incorrect, as you'll see where the geometric mean comes in. So in geometric mean, what you do is, instead of doing this addition, what you want to do is multiply them. So you want to multiply 3.3 by 88 and then take a square root of that, so you get 17.04, and then you do that for all other observations and then rank them here. So now you see that C is actually the worst user rating for C. The higher user rating is for D, followed by A and B. Now is this correct? What we can do is take a normalized arithmetic mean and see if that matches this particular ranking that we have. So to normalize, by what I mean by normalizing is what you want to do is divide the observations for this by the maximum value in that scale. So the maximum value for this column is 5. So you're going to go ahead and divide 3.3 by 5, 4.3 by 5, and so on. And similarly for this column, the maximum is 100. So we want to go ahead and divide each of these observations by 100, and then take the mean of those values which are normalized. So here we are going to add the value that is after division, after we divide 3.3 by 5 and divide 88 by 100, and then divide, and then take the sum of that, divide by 2, we get a value of 0.77, and then we do that for all other observations. And then if we go ahead and now rank these, we again see that D is actually has higher user ratings as compared to all other brands of laptops, and C does have the lowest user rating. So this is one use case where geometric mean actually makes more sense to use as opposed to normal arithmetic mean. Okay, next let's look at harmonic mean. Now again, in this case I've created this example just to show you where harmonic mean would make more sense. Here what we have is an experiment where you started measuring the drain rate for the battery. Okay, so at what percent per hour does the battery life reduce when you start measuring it? So in here, at the first 150 minute, you have the drain rate for that particular laptop. The battery starts to drain at 10% per hour. Okay, so you have around 75% of the battery life remaining. In the next 75 minutes, the battery drains at 20% per hour, and then only 50% remains of the battery remains. After that, for 37.5 minutes, the battery drains at a rate of 40% per hour, and that leaves only 25% of the battery charge remaining. And then finally, in 18.75 minutes, the battery drains very rapidly at 80% per hour to completely drain the battery with zero charge remaining. Now, if the question here you want to ask is, what is the average battery life for that laptop? Here, if you go ahead and simply add these up and divide by 4, you get a battery life of 37.5. But is that correct? And soon you'll see that that is not actually the case. It's not correct. If you take harmonic mean, to take harmonic mean, what you want to do is take a reciprocal of the observation and take an average of that. So, and then take an inverse of that. So that's shown here in this formula. So 4 is the number of observations. We have 4 observations, and then that's in the numerator, and in the denominator we have 1 by 10 plus 1 by 20, 1 by 40, and 1 by 80. These are the reciprocals of these observations. And then when we calculate this, we want to take an inverse of that, and therefore this is exponentiated to power of minus 1, and you get a harmonic mean of 21.33% per hour. So that's the drain rate for that laptop battery. So that's completely different than 37.5. Now, if you think if it makes sense, let's look at this value right here. The total percent battery drained. So we are draining 100% of the battery, right? We go right up to 0. And the total time it took us to drain that battery, right here we see that the total time was 281.25 minutes or 4.6875 hours. Okay, so if we divide that, we do get the number 21.33. So we can then say that yes, harmonic mean is helping us in this case to identify the average battery drain rate in percentages per hour. Percentages per hour. So the harmonic mean is correct, and the arithmetic mean in this case is incorrect. So just a side note, the harmonic mean is helpful when you are trying to get averages of rates. Okay, that was it for this video. I hope in this video you learned how descriptive statistics works and gave you some intuition on what goes on in the background, because when you are writing the code in next videos in Python, you won't see this inside story that's happening to give you an intuition of what actually how to interpret the value that you get in the output of the code. If you have any questions or doubts, please let me know in the comments below. I'll try to explain them. Or if you have any additional statistical concepts that are basic you try to understand, let me know in the comments below. I'll try to create a video for that as well. And if you enjoy the content, if you learn something new from these videos, please like, share and subscribe. It helps me stay motivated to create more interesting videos for you all. I'll hope to see you all in the next video. Thank you.